Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over two exercises where we are going to approximate a function value without using a calculator. Okay, so what are those functions? In the first case scenario, we have 1 over x squared and n equals 4 and c equals -2. So we're going to use a Taylor polynomial, fourth Taylor polynomial with the given c value -2 for the function 1 over x squared to estimate the value of 1 over x squared at -2.1. And you can go ahead and, in fact, write down the exact value of the function, let's say in part A, 1 over -2.1 quantity squared. But without using a calculator, it's not easy to estimate that value. What we do in general is that we expand we look at the nth Taylor polynomial written at c equals -2 with n equals 4. So it's the fourth Taylor polynomial in that regard. And all we do is just plug in c equals -2 in that case. X equals -2.1 in that case. And whatever it spits out, then that would be the approximate value. And we do the same thing for f of x equals ln x. And we're trying to approximate ln 2.1 by using the fourth Taylor polynomial at c equals 2. So these are approximations. So to get a better approximation, obviously you have to go to the higher order Taylor polynomials. But I will see, I'll show you what the error could be along the way. If you were using a calculator, what would you get? And then if you were using the Taylor polynomial, what would you get? So we're going to compare those side by side. I have one video for each. Let's get started.
All right, let's start with part A. So the function is 1 over x squared, and we're going to retain the Taylor polynomial of order 4. And Taylor expansion is going to be, or Taylor polynomial is written at c equals -2. And by using the Taylor polynomial, I'm going to try to guess what the value of this function at -2.1 could be, okay? So to remind you what the Taylor polynomial is, just see that if f has n derivatives at c, the Taylor polynomial follow this form. This is the Taylor polynomial for f written at c. So we're going to follow this form for the given function. So to achieve the objectives here, we need to have all the derivatives of f up to the order written, and they should be evaluated at c equals -2. Let's do that. All right, so I just listed all of them, including f. So we're gonna use the power rule for differentiation to find all the derivatives up to the order 4. So this would be -2x to the -3. In other words, -2 over x cubed. Okay. This will be 6x to the power of -4, 6 over x to the 4th, and -24x to the -5, -24x to the 5th, and then finally 120x to the -6, 120 over x to the 6th. Okay. All right, so I'm going to evaluate them at -2 all the way. Okay. All right, let's do it real quick. F of -2, 1 over -2 squared, that's 1/4. Okay. And f prime at -2, -2, let's write it, -2 cubed. Okay, -2 cubed is -8. So -2 divided by that is 1/4. We are trying to, by the way, keep the exact values here. Please don't use your calculator to get the final result, because that could come with decimal places. We don't want that. And if you want, you can pause the video. You can find all of those values with your own pace. Let me just list them down. So once you pause the video and once you use your calculator, you can actually get all of those values by yourself. Okay. All right, these are the other values at double prime at -2, all the way of the fourth derivative at -2. So now all I'm going to do is to write down P4 of x. Okay, so let's just do it. F of, well, let me just write the long expression of that. F of -2 plus f prime at -2, x minus c, so x minus 2, x plus 2, plus f double prime at -2, divided by 2 factorial x plus 2 squared, plus f triple prime at -2, x plus 2 cubed. And then the fourth derivative evaluated at -2 divided by 4 factorial x plus 2 to the fourth. Okay. All right. So let's plug in those values. So 1/4 plus another 1/4 x plus 2, 3/8. 3/8 divided by 2 factorial is 3/16, x plus 2 squared, and then 3/4 divided by 3 factorial. 3 factorial is 6, so it's, I think, 1/8. After you simplify it, 1/8 cubed. And then finally, check this by yourself, 5/64, x plus 2 to the fourth. So this is P4 of x. Okay. Going back to the question statement, we're trying to approximate f of -2.1, which is in fact 1/-2.1 squared. This one, right? What is this approximately equal to? That's what we're after. So the answer is like P4 at -2.1 is the answer. So essentially, you are going to go back here and plug in -2.1 for x. So this would look like 1/4 plus 1/4 -2.1 plus 2. So that makes it -0.1 plus this -0.1 squared, 1/8 -0.1 cubed, 5/6 -0.1 to the fourth. And this should be 64, by the way. Okay. And this time you can use your calculator because we're using an approximate, we're having an approximation. So if you do the crunching numbers with your calculator, let's see, I should have 0.227 approximately if I keep 3 decimal places and round it off at the 3rd decimal place, okay? All right, so here's the visual of what we did here. We started with 1/x squared as a function, and we got the Taylor polynomial of order 4. Okay, so let me just show you what is the meaning of like having order 1, 2, 3. So like this is order 1 approximation. So the purple curve is 1/x squared. The purple curve is 1/x squared, as you see, and the red one is its approximation, Taylor approximation. Okay, this is n equals 1. So let's go to n equals 2. N equals 2 is a quadratic approximation. And if you increase n from 2 to 3, so you get closer and closer to the curve. And if you just like put n equals 4, 5, see, like the more you put terms in the Taylor polynomial, the better you are going to approximate to the given function 1/x squared. So as you see that the red, so like merges with purple when you increase the order, let's say like 12 terms, 13 terms, and after some point you don't even realize like purple and red are the same, like are not the same, right? So they get very close to each other. So if I run this, as you see that when you increase the order, starting from the linear, quadratic, cubic, fourth order, you get closer and closer to the curve 1 over x squared in the neighborhood of -2. And then we were looking for we were trying to approximate f of -2.1. So that's we're looking at this value. So if you use your calculator to find 1 over -2.1 squared, this would be the value that your calculator would spit out. But what we did is we wrote down P4 of x, and then we looked at the approximation. The approximation is the Taylor approximation, n equals 4. So let's go to n equals 4 here, see what's going on. So that n equals 4, the exact value is like 0.226757, and the approximated value is like 0.226758. So once you round this number, it's a pretty good approximation, in fact. And if you keep more terms in the approximation, as you see that the approximated value is just getting closer and closer to the actual value.